Okay, this should be just a really quick demo here. If you've heard me talk maybe in the past couple months, you know I've sort of like moved away from doing non-square style GAN models. And the reason for that is that while I love the fact that you can do non-square models, many of the, I don't know, non-NVIDIA tools don't really work with them. So for example, GAN space really requires squares. Other tools are like built by default to support square models. So in this case, I'm sort of moving away just because it makes using all those other tools much, much harder. So what I'm sort of recommending folks do now is that they just, if you have a series of like, say, 3x4 images, what you do is you actually squish them into a square, 1024 by 1024 or 512 by 512 model, and then you train on that. And then when you do the generation or whatever tools you're using on output, you actually like sort of unfertile it. So you sort of unsquish them afterward. So this is just a quick demo to sort of show how you can do that using dataset tools. So as you'll see here, I have a bunch of images. They are all 768 by 1280. And what I want to do is just take this folder and squish it down in a 1024 by 1024. Now, there's probably lots of ways you could do this the right way in terms of like, making sure your interpolation methods are right or whatever. We're just going to use the bilinear interpolation that's already built into dataset tools. So there's probably ways to tweak this a little bit, but I actually find that it generally works fine, especially, style GAN models tend to have a little bit of compression or just like a little bit of loss anyway in terms of quality. So I think it's fine that we do it this way. So I'm just going to go ahead and copy this path using Command C. I'm going to jump over to the terminal and use dataset tools. And I'm just going to do Python dataset tool. We're going to use the process type of Resize. And then we're going to give the input folder of that path, so Command V. And then the output folder is just going to be ./output/ let's say combined 1024 and add a slash at the end. And then what we want to do is, instead of saying max size, which we usually do to sort of keep the size the same, we're actually just going to pass in a height and a width. So this is just going to say resize it to this exact dimension. Now, one thing I do recommend is that all of your images in your input data set be the same proportion, right? If you have some squares and some rectangles and some horizontals and some verticals, like the model is going to try to learn all of those, and then when you unsquish it, it's going to get really messy. So make sure that your input folder has the same proportion. That way you always reshape it after generating images or video to that exact same proportion. That way all the features that the model has learned are the same. So just to note that as well. So we're going to go ahead and just run this. I think this should be pretty quick. We can go ahead and check and see what we're getting here when we go to our dataset tools library and go to outputs and combine 1024. One thing you'll note is that this is something I need to fix in the repo before. I'll do this in like the next couple days. The output size is wrong. It's matched whatever max resize is. I'll switch that in just a minute. You'll see here we've sort of mess with the proportions of our images. So now I can train on this, and then when I am done with the model, I can actually go back and resize it when I generate outputs. Pretty straightforward, pretty easy, but I do generally find this works better. And you can use all these other tools like GAN space or network bending or other things, because it's sort of built in with the idea that 1024 by 1024 is going to be the size of your model. So that's it for this video. It's pretty quick, and if you have any questions, let me know. See you next time.